Hello guys, welcome back to part 2 of multiplying and dividing rational numbers. In this screencast, you will learn how to divide rational numbers. Okay, go ahead and try these, pause, and then come back to check the answer. This is a review to see if you are comfortable with dividing fractions. Alright, welcome back. Let's go ahead and check the answers. 6 divided by 1/3. Remember, with division, unlike with multiplying, we need to remember what is called the reciprocal. So we put 6 over 1. We switch division 2 times. And then we get the reciprocal of the second fraction. Remember, reciprocal means to flip. Okay, now we are ready to multiply. So 6 times 3 is 18. And of course, the over 1, we do not have to put it. So this answer here will be 18. Alright, for the second one, here we have a mixed number. So similar to multiplying, whenever we see a mixed number, we need to change it to improper fraction. So this will be 2 times 10, 20, plus 1, 21. Let's do it below. 21 over 10 divide by 3 over 5. Okay? 21 over 10 stay the same. Division turn 2 times. And we flip the second fraction. Okay? Now, the next step here will be to simplify before we multiply the numerator and the denominator to prevent us from dealing with large numbers. So 5 and 10, their GCF will be 5. So 5 cancel, 10 turn 2. 21 and 3, GCF again here will be 3. 3 cancel, and 21 will become 7. So here we are left with 7 over 2. Now, this here is improper. To change it back to mixed number, we just simply divide it. 2 goes into 7 3 times, and the remainder will be 1. So we will get 3 1/2. Okay, so hopefully you didn't have any problems doing these two problems to review what you guys learned previously in 6th grade. So now let's move on to 7th grade things, where we actually have negative symbols. Okay, so what we need to know today is reciprocal or multiplicative inverse. If you want to sound smart and intelligent, you will say multiplicative inverse. Save the little flip thing for elementary kids, but now you guys need to say multiplicative inverse, which is the same as reciprocal. So here the definition is the flip of a number. When you multiply a number by its reciprocal, the result will always be 1. Okay, so here example will be 3. The reciprocal of 3 will be 1/3. Why? Because 3, remember, is over 1, and then we flip it. 2/3, the reciprocal will be 3 over 2. Non-examples will be 3 and -3. 2 over 3 and -2/3. These guys will be opposites. Yes, those guys will be additives inverse. Alright, so here go the steps for dividing rational numbers. Again, it is nothing new, except here this time we are dealing with a negative symbol. But we still follow the exact same steps for dividing rational numbers, except here we want to remember the rules for dividing integers. Okay, so let's go ahead and do this example. If we have any mixed number, as always, change them to improper. So here we will have -5 6 divide by, now this one here is a mixed number, so we must change it to improper. 7 times 7 will be 49, plus 1 we get 50 over 7. Okay, now let's go. Okay, the next step will be to multiply by the reciprocal. So remember the rule for dividing by fraction. Negative 5 over 6 stay the same. Division turn to plus times. And 50 over 7, we flip it. Get the reciprocal. Now the next step would be to go ahead and cancel if possible. Let's copy this down for step 3. Okay, so now 6 and 7 have nothing in common. However, 5 and 50, the GCF here will be 5. So we can cancel out the 5 and the 50 turn to 10. So now we are ready to multiply. Alright, the top one will be, of course, negative 7 over 6 times 10, 60. So here's the answer, negative 7 over 60. Remember from the beginning, we were multiplying a negative and a positive. So our answer we knew would be a negative. And then if this was improper, we will go ahead and change it if necessary, but that's not necessary in this case. Okay. All right, let's go ahead and do some practice. Alright, now go ahead and try these and then come back to get the answer. Alright, now welcome back. Let's go ahead and solve these together and check your work along the way. Here we have 2 divided by 7/8. First thing we want to do here is to put the whole number over 1. 2 over 1 division turn into times. And flip the second fraction, get the reciprocal. Now we cannot cancel anything here, so we have no choice but to go ahead and multiply. 2 times 8, 16. 7 times 1, 7. Now this here is improper, so we need to change it back. 7 going to 16 2 times. Remainder will be 4. And here is our answer, 2 4/7. Right now, let's go on and do the next one, which is this. Nine tenths divide by 6. Now, remember, wherever you see a whole number, please put it over 1 so we don't forget about it. Okay, so 9 tenths here stay the same. Division turn 2 times. This time we get the reciprocal of 6, which will be 1/6. And then now the next step would be to simplify anything if we can. Now 9 and 6, their GCF will be 3. So 9 cancel and turn into a 3, and 6 cancel and turn into a 2. And now we can multiply. 3 times 1 is 3. 10 times 2 is 20. And here's our answer, 3 over 20. There's no need to reduce because we already did it here. Alright, next one. Negative 10 half divided by 3/4. Okay, so first thing we want to do is to go ahead and change the mixed number to improper. 10 times 2, 20, so that will be 21 over 2 negative divided by 3/4. Now I'm dividing a negative and a positive, so my answer will be negative. Now let's ignore this guy. Alright, so 21 over 2 stay the same. Division turn 2 times, and we get the reciprocal of the second fraction, which will turn into 4 over 3. Now let's see if we can simplify before we move on. 2 and 4, 2 cancel. 4 turn into a 2. 21 and 3, 3 cancel. And 21 turn into 7. Okay, what we are actually doing is divide by 3. And we divide by 3 because 3 is their GCF. Now we are ready to multiply. 7 times 2, 14. Oh, that's it. So the answer here is 14. But my answer here is supposed to be negative. So negative 14. Easy, right? Alright, last one. Ooh, this is long. Okay, but nothing to worry about. Remember here, there's plus and then there's division and there's parentheses, so we need to make sure we follow what? Yes, the order of operation. Okay, so remember, whenever in an expression you have different type of operation, we need to follow the order of operation. So here, let's go ahead and simplify the parentheses. 2 and 3, remember, whenever we are adding them, they must be cut the same way. So we need to find their LCM. In this case, 2 and 3, they're both prime, so the LCM will be 6. So we multiply 2 by 3 and 3 by 2. Alright, so now we are ready to write their equivalents. 3 over 6 plus 4 over 6. Okay, so now let's go ahead and add them. This will be 7, 6 divided by. Now I'm also going to go ahead and change this to an improper since it's mixed. So 1 times 2 is 2, plus 1 is 3. Okay, now we just follow the rules. 7, 6. Division turn 2 times. 3 halves turn to 2/3. Now let's go ahead and simplify anything if we can. 3 and 7 have nothing in common. Those guys are prime. 2 and 6, 2 in common as their GCF. So we cancel out the 2. And 6 divided by 2, we get 3. Now we are ready to go ahead and multiply. 7 times 1 is 7. And 3 times 3 is 9. So my answer here will be 7 ninths. Okay, alright guys, well that's it for today. Hopefully you guys don't have any questions. I do have a challenge problem, but let me see if it will show up correctly. Okay, great, there it is. This is a challenge problem and this is worth 5 points. Okay, once you get the answer on how to solve it, you can send me the answer to Edmodo. But in order for you to get those 5 extra credit points, you need to send it to me before class. Okay, I need to get your answer and the way your work before class. So this is a challenge question for you as a bonus. And that's it for today. Remember, if you have any questions on what we covered today, please post your questions on Edmodo. Now this one, we will do it in class together, so do not keep asking me about it. That's why it's a challenge problem. That's why it's for extra credit. Okay, so that was it for today. Hopefully you guys did understand this very easily and are ready to apply this in class. And I'll see you guys then. So have a good one. Bye-bye.